Hey everyone, my name's Braden. We're going to go over how to create a box plot in Python. Specifically, we're going to use Seaborn and a little bit of Matplotlib to make our box plots. We're first going to create a simple box plot like this one, and then we're going to beautify it a little bit like this. And then we'll go over how to create multiple box plots in a single figure, and then we'll go on to how to design our box plots to draw our viewers' attention to a specific area. So first, we're going to start off by importing the usual pandas. We'll also import NumPy, Matplotlib, and Seaborn. If you're using Jupyter notebooks and your plots are not appearing, you may have to include the command %matplotlib inline. For me, I don't need to include that, so I won't, but just in case you're having problems, that might be your solution there. So I'll run this. And I spelled matplotlib incorrectly, so we'll fix that and run it again, and then we'll import our data. So I've created a fake set of data where customers reviewed 5 different products. This data is available on my GitHub. I'll leave a link to that in the description below. It also has a Jupyter notebook that explains each of these steps in detail. So we'll read that in and display it. So we see P1 or product 1, satisfaction, P2, P3, all the way to 5. And these are based on multiple questions, so they're scales. So to create a really basic box plot, we can do that with a simple one-liner. SNS box plot, so we're using Seaborn. We're going to pass in the data that we want to create the box plot from. So we'll create it from this first column, satisfaction. And if you're not using Jupyter notebooks, you will probably have to use plt.show. We don't have to if we're using Jupyter notebook. It will just give us this little bit of information here. If we include it, then that information won't be included. Creating a box plot in Seaborn is as simple as that. If we wanted to create a vertical box plot, we can do that simply by using the orient argument. We'll copy the code from above and specify orient v. We'll run that. And I'll just scroll down a little bit so you can view that. So those are simple box plots with Seaborn. They look really ugly, but it's really easy to make a simple box plot to see what's going on with our data. If you're hoping for something that looks a little bit better, we'll move on to that now. We can do it without too much work. So first, I like to start off by setting the style. For a single box plot, I like to use the style white. And then we can set the figure size and also create our figure and axes. So here I have specified the figure size as 10 wide by 2 tall. If you're using different data, you may have to play with these numbers a little bit to make sure that your figure is accurately representing your data and looks good. I've played around with this figure a little bit before, so I know that 10 and 2 works pretty good. Then we can create our box plot. We'll use the same command as above. We won't include orient v though, we'll have a horizontal one. This time we're going to specify the color of the box plot as plum. And we will specify the width as 0.5. So this will make the box plot a little narrower, not so wide. as these figures. They're really wide, and I think that doesn't look very nice. Okay, and now we'll just see what our box plot looks like. That's looking pretty good. I like the plum color and the dimensions of it. If you wanted to add a notch, I don't really like notches, but you can add it if you want by including the notch equals true argument. I'm just going to get rid of that. Alright, there are a few other things we can do to make this look a little bit better. First of all, we're going to want to add a title and X label. So we can do that with PLT title, and we'll add some very insightful box plot title. And we will say the font size is equal to 14. Default is 12, I believe. And we'll add the X label. We'll call that satisfaction since it's customer satisfaction. Okay, and we've added our title and our X label here. Okay, and we'll want to remove some borders. I think the borders make things look a little cramped. With a single box plot, I like to keep this left border and this bottom border. These borders are called spines, so we'll despine. So let's run that and see how it looks. I think that looks a lot better. However, I'm noticing that our data goes from 1 to 5. So we'll want to have a range from 1 to 5 on this axis, just so the viewer will know that that's the range of the data. So we can add the full range to the x-axis. We'll just say values to be clear. And we'll use the PLT xlim, and we'll include 1, 5 because that's our range. And just to tidy it up, we'll only have whole numbers on this x-axis here. So we'll do that by specifying our ticks, and we'll use np arrange. And we're starting at 1, and we want to go up to 6, but not including it. And our steps will be, so let's see how that looks. Alright, so that's looking better. The x-axis is cleaned up a little bit, only has whole numbers, and it has the full range of data there. Just to get rid of this, I'm going to say plt.show. So from an outsider's perspective, these numbers probably don't have much meaning. One might assume that 1 is less satisfied and 5 is more satisfied. However, we can make this more clear by adding a little bit of text for our strongly disagree and strongly agree. So we're going to have our text surrounded by a little box, and we will do that by creating a variable called props. And we'll create a dictionary box style equals round, face color equals plum, and we'll set alpha to equal 0.2. So this will provide our text with a little box. I think it looks pretty sharp. I'll show you what that looks like in just a second. We'll add text to our figure by specifying our axis.text, and we'll set the locations. This takes a little bit of playing around, but I've already done that for us so that we don't have to spend our time now trying to figure out exactly where to position the text. We'll set the font size to equal 12, and we're going to call BBOX or BOX, or maybe BBOX, and we'll set that equal to our props variable, or the box properties that we included here. We'll copy that, and we'll create our strongly agree text, and we'll want to set the location to 4.5. This is our x value, so 4.5 around here, and 0.4 will be around there. Okay, and let's run this, see what it looks like. Okay, that looks pretty good. The one thing that I'm noticing is that our strongly agree kind of spills over the figure, so we may want to move that over just a little bit. Let's try 4.4, and that looks pretty good. Everything's lined up here. So now it's time to save our figure. So we can do that with the plt save fig, and we will specify what we want to call it. So I'll say sat for satisfaction box, and this is product 1. And I like to save as a PNG. You can also save as a JPEG. There are a few commands that you might want to include. So DPI, for us we'll just use a DPI of 300, and we can also specify the argument transparent is equal to true. So that will make all of this transparent rather than white. I like that effect. I don't think it's very useful very often, but if you need it, there it is. I'm going to remove it though. So I get in the habit of specifying tight layout. Sometimes when you save a figure, the elements, the actual graph, will spill off of the image, so it'll get cropped. This will just help and make sure that everything stays on. Alright, and I'm actually not going to save this. I think this figure looks a lot better than our figures that we had up here. If you disagree, you're more than welcome just to use the simple boxplot command with Seaborn. If you're wanting to compare multiple box plots together, we can include all of those on one figure. It's relatively easy. I'll show you how to do that. So we will set the style to white grid. This will include a grid, which I think is a little more important when we have multiple box plots on a figure. And we'll set the figures and axis, and also specify the figure size. This time we'll go 8 by 6, and we're going to create our box plot and save it to G as in graph. So we'll use SNS boxplot. This time our data is going to be the entire data frame. If we wanted to specify what columns we wanted to use, we could specify the column names here. So P1 satisfaction, P2 satisfaction, and so on. We're going to use all 5, and since our data frame only has those 5, we can just say data is equal to our data frame. And the width of each of our box plots we're going to say is 0.7. We'll add a title real quick. plt title. And this is another insightful title. We'll specify the font size as 16. So let's run that and see how it's looking. And I'll scroll up. We have a little bit of an error here. Oh yes, I misspelled title. So I'll run that again. And I'll add plt.show for the next time we run it. So this is looking pretty good. So white grid includes these grid lines here. When we have lots of different box plots, it's nice to have the grid line so we can see where the data points are. What we have for our X value labels is just the variable names. I don't find that this looks very good or is very insightful. So what we can do is specify these value names. So we'll create a list with our X values in it. To save time, I've already written out that list, and I'll copy and paste it here. So I've written out each product name. So product 1, and then this \n will put the satisfaction on another line. Okay, now that we've created that list, we'll need to set X values as X tick values, We can do that with plt xticks mp arrange. We'll say 5 because there's 5 values in there, and we'll assign it x values. So let's run that and see if it worked. And it looks good. We have our product 1, and then satisfaction is on the next line for each of these product names. That's a lot better than what we had before. So just as we had before, we want to clean up these values here a little bit. So we will set y-axis values, whole numbers only. So we will assign a list of the y values that we want to y-int. 1, 2, 3, 4, 5. I can count to 5. We will assign our y-ticks, the y integer values that we just created. Okay, and let's see how that looks. All right, that looks good. So we may want to tidy the borders up a little bit by removing them. We can do that just like we did above by specifying SNS dspine, and this time we'll say top equals true, right equals true, left equals true, and bottom equals false. So we're saying that this top spine we want to remove, this right spine we want to remove, this left spine we want to remove, and we're going to keep this bottom one. And let's scroll down a little bit. When we remove the bottom spine, it doesn't include a grid line here. So that's why we want to just make sure that we say false. We don't want to remove that bottom spine. And that looks better where it includes that grid line there. So these colors look pretty good. But let's say we had a different set of colors we wanted to use. We can set colors of box plots. We'll do that by creating a list of our colors. So these colors are Seaborn colors. You can look up online different Seaborn colors. You could also use hex codes. So we'll use plum, green, orange, blue, and red. Then in order to assign those colors to our box plots, we will create a dictionary and zip our X values with our palette or our colors. So what we're doing here is creating a dictionary where our X values are paired with the color that we want. So our product 1 is going to be zipped together with plum, product 2 zipped with green or G, product 3 with orange, and so forth. And then we're going to loop through that dictionary. So this is going to loop through 5 times. So it's going to loop once through 0, and then 1, 2, 3, 4, because we're going up to 5 but not including it. And we're going to call the artist method. So this is getting into some advanced Matplotlib features. If you don't understand everything that's going on, that's all right. Just as long as you know how to adjust things so that you can get the outcome that you want. So if you wanted to include different colors, you'd specify that there. If there were less colors, one less color, then you would say 4 here rather than 5, right? And you want to make sure that this matches these up here. Otherwise, Seaborn will just assign Seaborn colors to anything that you don't have assigned. And one last little bit of code to add to this loop. We'll say my box set face color, and then call our dictionary and say x values I. What we're doing is we're creating a list of the colors that we want to assign to our box plots, and then we're creating a dictionary that contains the x values and the colors that we want assigned. And then what we're doing is actually assigning those colors to each of the box plots by creating a loop. And then what we do in this loop, for each key in the dictionary, we'll assign the value to the face color of our box plot. So we'll run that. It's a little complicated, but we're able to set our own specific colors for each of these box plots. All right, that looks really good for a set of box plots here. However, we are using color rather arbitrarily. This doesn't show our viewers where they should be focusing. If we change the color scheme up a little bit, we can actually help draw attention to the most important factors. Perhaps we want them to really focus on product 3 that's super low. Also, we can change the order of our box plots to help guide our viewer along to interpret the data a little bit better. Right now, everything's kind of scattered about. If we order these in descending order, it can help our viewer to know what exactly to focus on. So for our final little bit of code, we'll fix this up just to make it as impactful to the viewer as possible. I'll go through that really quick. So we're going to reorder the columns in descending order. I'm just going to copy over some code that I have written already. So we can create a new data frame with the order of the columns that we want. So if we look up here, we see that the highest median value for a product is product 1, followed by 5, 4, 2, and then 3. So we'll have that as our order. Grid style the same. We'll create our figure and axis. We'll create our box plot. So this time we're passing in our ordered data frame. We'll use the same title since it's so insightful. So we'll also create a list of our X values just like we did before. Remember this time though, it's important to change the order of our X labels. We'll assign our X labels and then we will set our Y values. We'll remove our borders or despine. And then we will set our colors. So this time I've used hex codes here. So we want the first 4 box plots to have this grayish type color here, and then this light reddish color. And we're assigning our values just like we did before. And let's see what happens. The figure that we get now is not quite as exciting as the one above. However, we do help draw the attention of the viewer to the problem areas here with this red color. So we can have an insightful title that helps the viewer see, oh, our products are pretty good, but we definitely have a problem with product 3. So we may want to pay a little more attention to that. If you made it through this whole video, great job. That was a lot to go over. Box plots can be really simple to make, but we can also add a lot more to them to make them a lot more insightful for our viewers. Thanks for watching this video.